Hello, my name is Mirji. I am assistant professor in mechanical department of WIT Solapur. For this FTP activity, I have selected the course Automatic Control Engineering, and my topic deals with mathematical modeling of control system. Previously, I have discussed about basics of control engineering. Now, in this presentation, I am going to discuss about mathematical modeling of control system. First of all, what is meant by mathematical model? That is the question. Once a physical model of a physical system is obtained, then the next step appears to be a mathematical model, which is nothing but a mathematical representation of the physical model through use of appropriate physical laws. Depending upon the choice of variables and the coordinate system, a given physical model may lead to different mathematical models. A network, for example, may be modeled as a set of nodal equations using Kirchhoff's current law, or a set of mesh equations using Kirchhoff's voltage law. A control system may be modeled a network, for example, may be modeled as a set of nodal equations, as I told just now. Also, control system may be modeled as a scalar differential equation describing the system or state variable vector matrix differential equation. Mathematical models of most physical systems are characterized by differential equation. Mathematical model is linear if differential equation describing it has coefficients which are either functions only of the independent variable or are constants. If the coefficient of describing differential equations are function of time, then that is called as a linear time varying. If the coefficient of the describing differential equations are constants, then the model is linear time invariant. This was the basic explanation about mathematical modeling of a control system. Now we will move to the next slide, that is the step 1 includes modeling, where whatever things we have discussed, it is a part of first step. Second step carries analysis, that is stability, controllability and observability. Step 3 carries control law design. Step 4 carries analysis. Step 5 carries simulation, and last step carries implement, that is implementation. Now we will move to the next slide, which is basically analogies, deals with analogies. If you see, analysis of mechanical systems carries two types of motion, that is translation motion and rotational motion. What is the difference actually here? In translation motion, the three elements which we are considering, that is mass, damping coefficient, friction, and the third part is stiffness, that is spring stiffness. In rotational motion, the same way, torque we are considering, and also we are considering moment of inertia. Here the two elements are different, and in translation motion it is force, it's like for mass, spring stiffness and damping coefficient. But as in analogous system, there are two analogies we are going to make, that is force voltage analogy and force current analogy. In force voltage analogy, the force is analogous to voltage, and force current analogy, the force is analogous to current. So in the next slide, it is easily we can understand through this table, that is what is force current and force voltage. In this mechanical system, generally here translational mechanical systems only it is shown. First we will see how the elements of translation mechanical systems means it is analogous to electrical quantity. For force voltage analogy, the force is analogous to voltage, velocity is analogous to current, displacement is analogous to charge, mass is analogous to inductance, and viscous damping coefficient, that is B, that is analogous to resistance, and spring constant is analogous to reciprocal of capacitance, or reciprocal of spring constant is analogous to capacitance, we can say like that. In force current analogy, it is different, where the force is analogous to current. The difference is that the inverse of friction, means like inverse of viscous damping coefficient, is analogous to resistance. Mass is directly analogous to capacitance, and inverse spring constant is directly analogous to inductance. So through this table, we will get to know what is actually analogous quantities and through the mechanical system and electrical system by comparing both the quantities. This table explains everything about analogous quantities. So this was the learning objective, to know what is force voltage analogy and force current analogy, and what is actually mathematical modeling of control system. Thank you.